Redox reactions are chemical reactions where both oxidation and reduction take place simultaneously. In fact, oxidation and reduction must occur at the same time. What is meant by oxidation and reduction? Well, there's several definitions, but it's worth keeping in mind that they are not contradictory. So if something is classed as oxidation by one of the definitions, it will be oxidation by the other definitions as well. So let's look at the definitions of reduction and oxidation one by one with examples. We'll try to not get too confused by the vocabulary. The first and simplest definition of these reactions is that oxidation is the addition of oxygen to something, whereas reduction is the removal of oxygen from something. So if we take a look at this reaction, which is a redox reaction, we can see that the iron has lost oxygen, going from iron oxide to just iron with nothing on it. So it has been reduced, lost oxygen. At the same time, the carbon has gained an oxygen atom, so it has been oxidized, goes from carbon to carbon dioxide. Hopefully that's pretty clear. Oxygen gets added, it's oxidized, oxygen gets removed, it's reduced. We can see that with another example here. So the magnesium gains oxygen, it's oxidized. The oxygen goes from being stuck to another oxygen to being with a magnesium, so the oxygen has lost oxygen, and it is reduced. So that's the first definition of redox, gain or loss of oxygen. The second definition of redox reactions is applied when there's no oxygen present in the reaction. Try not to get confused, even though it's called oxidation still, there's no oxygen involved. The second definition of redox involves electrons instead of oxygen. You'll know about atoms gaining or losing electrons to become ions. This is a form of redox. This is a redox reaction. If an atom loses an electron, we say it has been oxidized. If an atom gains an electron, we say it's been reduced. There's a great mnemonic to try and remember this: oil rig, O-I-L-R-I-G. This stands for oxidation is loss of electrons, reduction is gain of electrons. Oil rig. Good way to remember it. So let's look at this example here. We can see that the zinc has displaced the copper. Hopefully you remember displacement reactions, where a more reactive element takes the place of a less reactive element in a compound. That is a type of redox as well. So if we take a look at the electrons involved here, the zinc goes from Zn with no charge, zinc, that's an atom, an element, to zinc with a 2 plus charge, a zinc ion, because it's now in an ionic compound. So to go from neutral to positive, it loses electrons. Remember, electrons are negative, so losing them gives a positive charge. So zinc has lost 2 electrons. By our definition from before, it has been oxidized. Oxidation is loss of electrons. The copper, meanwhile, has gone from being a Cu2 plus ion in the copper chloride compound to being neutral. It has gained electrons, so it has been reduced. Reduction is gain of electrons. Again, let's see another example. In this reaction, the chlorine has gone from being neutral to having a -1 charge. It's been reduced because it gained electrons, whereas the bromine has gone from having a negative charge to being neutral. It lost an electron. It's been oxidized. Oxidation is loss of electrons. Even though there's no oxygen present, that's still what we call it. So that's the first 2 definitions of redox right there. For the third definition of reduction and oxidation, we have to introduce a new concept. This is called the oxidation state or the oxidation number. This is a value that is not the same as charge. It's not the same thing as charge. It's separate from charge. We assign this value to an atom in order to keep track of the redox reactions. So it's a little bit of a confusing concept when you first encounter it, because it's not charge, it's not the number of bonds or anything else. It's another value that we assign to them. And once we've assigned this number, we can see how it changes in a chemical reaction. If the number goes up, oxidation has happened. If the number goes down, reduction has happened. So our third definition is oxidation is an increase in oxidation number, reduction is a decrease in oxidation number. How do we know what an oxidation number is? Well, there's a set of rules that we have to remember. So here's the set of rules. I'll read them out, pause the video. The oxidation number of elements on their own is 0. If I have iron on its own or O2 on its own, it's an element, the oxidation number is 0. The oxidation number of an ion is the same as the charge on the ion. So if I had Zn2+, its oxidation number is 2+, and its charge is 2+. If I have O2-, it's O2-, it's 2- is its oxidation number. All of the oxidation numbers in a compound have to add up to 0. So if we know one oxidation number, we can work out the rest of them. The oxidation number of oxygen in a compound is always -2. The oxidation number of hydrogen in a compound is always +1. That helps you work out the other things in that compound. So using that, we can assign oxidation numbers and we can see if they increase or decrease. In this example, we'll go through each atom and assign its oxidation number. The aluminium and the oxygen on the left are both elements, so their oxidation number is 0, 0, and 0. On the right, the aluminium is an ion with a 3+ charge, so it has an oxidation number of +3. Because remember, one of the rules is the ion charge is the same as the oxidation number. Oxygen is always -2. That's one of our rules. The oxygen in compound is going to be -2. So we can see that the oxidation number of aluminium increased, going from 0 to +3. It's been oxidized. The oxidation number of oxygen has gone down from 0 to -2. It's been reduced. Let's look at another example which does not involve ions. On the left is carbon monoxide. This is a covalent compound. There's no ions. But from our rules, we know that the oxidation number of oxygen is -2. So to make it add up to 0, the oxidation number of the carbon must be +2. The oxygen is an element, so it has an oxidation number of 0. On the right is carbon dioxide. The oxygen in the compound is still always -2, but now we have 2 of them, for a total oxidation number of -4. Each atom only has -2 though, and I'm talking about the total. To balance it out, the carbon now has to be +4. Don't mix it up, the carbon isn't charged. This is the oxidation number, a different value, different number. But we can see the oxidation number of the carbon has increased. It has been oxidized. The oxidation number of the oxygen went from 0 as the element to -2 in the compound. Its oxidation number decreased, it's been reduced. So there we have it, 3 definitions of redox. Oxidation is the addition of oxygen, the loss of electrons, and the increase in oxidation number. Reduction is the removal of oxygen, gain of electrons, and a decrease in oxidation number. One final thing. Chemicals in a redox reaction can be reducing agents or oxidizing agents. Some people think these names are a little confusing because oxidizing agents can cause other things to be oxidized. Oxidizing agents are themselves reduced, whereas reducing agents cause other things to be reduced. Reducing agents are themselves oxidized. Alright, thanks for watching.